In this video, we're diving into a topic that might sound complicated, but is actually super cool once you get the hang of it. We're talking about complex numbers, and specifically, we'll focus on their rectangular form. Alright, let's start from the beginning. Complex numbers, they're not as scary as they sound, and you've actually seen parts of them before. A complex number combines two parts, a real part and an imaginary part. It looks like this. Here, the complex number z is written as a plus b times I. The a part is called the real part, and the b times I part is the imaginary part. But what's with the imaginary part? Well, it involves I, which represents the square root of -1. So whenever you see a complex number, just remember, it has a real part and an imaginary part. Now that we know what complex numbers are, let's get into their rectangular form. If we think of complex numbers visually, we can plot them on a two-dimensional plane. This is called the complex plane. In this plane, the x-axis represents the real part of the complex number, and the y-axis represents the imaginary part. So when we write a complex number in rectangular form, like z equals a plus b times I, it's just like giving the x and y coordinates for a point. As an example, we can take the complex number 3 plus 4i. In this case, a equals 3 and b equals 4. So we would go 3 out of the x-axis and 4 up the y-axis. If you draw a line from the origin 0.0 up to 3.4, you'll see it creates a right triangle with sides 3 and 4. This triangle helps us understand both the length and the direction of our complex number. Now let's talk about two important ideas that come from this: magnitude and direction. The magnitude of a complex number is its distance from the origin. For the complex number 3 plus 4i, we can find this using the Pythagorean theorem. The magnitude of a complex number is written with one vertical line on each side of the number. The square root of the two numbers squared is taken due to the Pythagorean theorem. The squares are calculated to be 9 and 16, which added together is 25. 25 is now easily found to be 5. So the magnitude of 3 plus 4i is 5. This tells us how far it is from the origin. Then there's the direction, the angle it makes with the real axis. This angle is super useful in polar form, but for rectangular form, we focus on a and b separately to locate the number precisely on the plane. Let's go through some more examples of complex numbers in rectangular form. -2 plus 5i. In rectangular form, the real part is -2 and the imaginary part is 5. So we'd plot it at -2.5 on the complex plane. Another example, 2 minus 3i. In this case, the real part is 2 and the imaginary part is -3. We plot it at 2.3. Easy, right? Next, let's talk about adding and subtracting complex numbers in rectangular form. It's actually pretty straightforward. To add two complex numbers, we just add their real parts and their imaginary parts separately. So if we take 3 plus 4, I plus 1 minus 2i, the real part is 3 plus 1 and the imaginary part is 4 minus 2. The result is 4 plus 2i. Easy as that. For subtraction, it's the same idea, just subtract the real and imaginary parts separately. Alright, multiplication is a bit trickier, but we can do it. To multiply two complex numbers, we use the distributive property, just like in algebra. Let's take 3 plus 4i times 1 minus 2i. We'll multiply each part. We have now gotten I squared. But remember that this, by definition, is equal to -1. Our answer is therefore 11 minus 2i. Alright, that's a wrap on the rectangular form of complex numbers. Let's recap. A complex number in rectangular form is written as a plus b times I, where we have a real part and an imaginary part. On the complex plane, it's like giving coordinates to locate a point, and we can add, subtract, and even multiply complex numbers in this form.